quickly can we develop a useful real-world business tool using ADA, specifically automated lead enrichment? So the problem that we've got in the business at the moment is trying to get cold email outreach to work. There are a specific couple of campaigns that we're trying to make headway on, target fairly new businesses. We have a list of those companies, individuals and their industries, but we don't have the contact details for them. I've got a bit of code that does this for me already. So what I'll do is I'll walk you through that, and I'll walk you through what we're going to have to do in order to automate it, because currently too few leads for too much effort. So this is the shape of the main script. It's fairly straightforward. We used ADA to develop it. It's not a highly interdependent network of stuff. It's more a sequence of scripts. It's run very hands-on, me in the terminal acting on the results that come back. Let's walk through the steps. Download the a CSV. So this is a shared Google Sheets that has a CSV URL. So I hard code that in there. First thing we do is we check Companies House. That's the main public UK source of information on the business that contains certain things we're interested in. Then we check the addresses. We can tell if that business actually has as a registered address an accountant's firm, which means an accountant's practice helped set them up. They've already got an accountant and we're not targeting those. Then we search LinkedIn for the company and the director. There's a couple of redundant steps in here that I've been meaning to get rid of. Firstly, we use Google Search API to come up with results on LinkedIn. It's much more efficient to bring up a link to LinkedIn's own search page. I'm aware that Microsoft is very much protecting this cash cow, this treasure trove of data, and does not want a plethora of businesses automatically scraping LinkedIn. It's against their terms of service. You have to log in as a user, and then all the actions that an automated headless browser would take on the platform are going to be very obvious. The way I do it here to get around that is the only thing I automate is construction of the search URL, and then I open it in a page and it's me and my mouse and my eyes and a human clicking to find the stuff. This was working absolutely fine, and we've certainly gathered a lot of data using LinkedIn just through this sort of shoulder surfing method, but it's still pretty slow. But we'll get onto some statistics as to what we do about it in a second. Then we go to search Google Maps. The next part is searching Google. So this uses the Google Search API to pull results. However, a human has to figure out whether the results are right or not. This is the first candidate for actually using a large language model kind of AI processing. I suspect that GPT-4 would be pretty good at looking at a web page and having some details about business and being able to give a confidence rating as to how likely it thinks that that web page belongs to that business. Then we do some scraping of relevant websites. It's still a manual process. So then we finalize that lead. That just asks me to type something in. We write it out to a file and we load it up into a Google form. This is because of another automation that I previously set up, where the Google form would put that information in a secondary Google Sheets, and my automated outreach sends an email out to them and chases up by text a couple of days later. The tone throughout is a genuine person trying to reach a genuine person. Being real as possible, even though I'm using an AI tool to do it, I think is pretty effective. If something is wrong with it, so maybe I've found that their registered address is an accountant's address, so they already have an accountant, or maybe I couldn't find any contact details, so they're abandoned because they're unreachable. That will throw as an exception. It'll get caught down here and we'll write them out as abandoned. And we keep counters of each, and we then have the stats. So the process would be at the start of the day that I would run through this for that day's leads, and then all of those leads with contact details would get dropped into the automated outreach process. Great. Only it takes a lot of time to get a few leads out. Most get abandoned. Loads are unreachable. If you think about a new business that hasn't filed its accounts yet and gets to the end of the first year and they're due, maybe they never traded. Or maybe they have an accountant, but they haven't got on with it. Or maybe they're just clueless and don't understand its importance. And so because they ascribe no importance to it, they ascribe no value to it, so they wouldn't be interested in purchasing anything to do with it. There's a lot of false positives in these leads, so I must get through them more quickly. Before automating, we should eliminate. So what do we stop doing that we're doing currently? The step with the biggest friction is LinkedIn. So let's look at some stats. So there were 300 plus leads processed. Those with any contact method that I would actually use, it was only 42. So that's 14%. If I can accelerate getting to those, that would be almost a 10-fold increase in speed. That's really worth doing. I pulled out some specific details to do with LinkedIn. I have to have the manual browsing approach if I'm going to actually not break the terms of service, and that's slow. Of those with contact details, how many came from LinkedIn? 20% of the mobile phone numbers? 20% of the emails? If I lose a fifth of my data because I no longer look at LinkedIn, but I am now 10 times faster, I think that's a trade-off that's worthwhile. That's the idea. We want to eliminate all these things that slow us down, that aren't unnecessary, that are not automatable. And then what's left, we can automate. So the thing I need to automate is web scraping. Scraping, say, the top handful of results from Google. I need a way of knowing whether that does actually belong to that company or not, because the top result in Google quite often is not, especially for a new business. That's what I need to do, and there's one tool that's going to help me. It's Ada. So let's give it a go. Right, so as you can see, we've removed quite a few steps like searching LinkedIn, searching Google Maps, navigating the website to scrape it the old and manual way, and we're left with a couple of things that we want to automate now. So we have this search Google step. That's the first thing we need to do. Take a look at the top search results and figure out, using a large language model API, what our confidence is that that's the proper website. This isn't always going to be easy. Some companies in this lead list are consultancy companies, and quite often they just do business person to person, maybe across LinkedIn, maybe across their professional network that way, and don't really have a website presence, and we're not likely to find it. For those, we're going to have top search results that definitely don't correspond to that website. We want to be able to rule those out fairly quickly. Likewise, we may find a few really large websites that have lots of pages, so we don't want to crawl the whole thing. We may want to look at things like privacy policy, terms and conditions. They tend to have email addresses in them. We might want to look at the about page, contact page, of course. We just want to know, is it likely to belong to this particular company, this particular director? And if so, does it contain contact details that we can use? So before we get into loading up Ada, adding the new functionality that we need, let's run it as is, just to verify things are working. So let's run this, and we'll see it's going to give us the output here. Start at line 0 as it suggests, and it's going to run through this CSV file with information and do only the automated steps that we've already coded. You see it scrapes a whole bunch of information from Company's House. It checks the company address type from Google Maps. It shows that it's a business address, and we've got a website there from Google search. I know that's not our website, so when we do make an automation that looks at the website to figure out if it belongs to the proper company, I want that to come back negative. The result here is the default result we're expecting. It's going to conclude that we are unreachable, because it currently doesn't have any logic to find contact details with which to reach us. So now let's use Ada to implement the automated steps that are missing. So the first part we want to automate is this part here where we're searching Google and we're searching for the company. So we'll click through to that and we'll see we've got some defined functionality here. I've got some intermediate files here that record the outputs of APIs, so we know what the structure is. Google search or results, that's the one we're looking for. We're going to want these, basically these items, these are the search results. And you can see there's lots of detail under each. I think the snippet is basically what we've got. We first need to hone our search terms in Google to exclude anything based out of the UK. There is a parameter I can use in the search API. It's called CR here, and it restricts search results to documents originating in a particular country. So we want a CR query parameter for our search. Let's add that in, then see if we get a better list of results. So that seems to have done the trick. I've added this CR country UK parameter to my call to the programmable search, and you can see that the result down here, it found our website first rather than any of the foreign ones within this search Google function, where we're currently just saving the first result naively. We want to replace that. We're going to call a function that doesn't yet exist, and then we're going to ask Ada to write that function. So we've replaced that code. So we're going to take the best match from this function that doesn't exist yet, best match from search results. Let's fire up Ada. Simply type Ada in the command line. I've already installed it. I actually installed it within this same virtual environment because I quite like to keep things related to each other in the same place. You could have it installed globally, of course. This is where we're going to enter our request to implement the functionality we need. It helps to add the specific files we want to work on. So I'm going to add main.py and search google.py. With that and universal C tags being able to look at the structure of the whole repository in the background, we should be able to get what we need with just those files added. Main, you see it does this auto completion, which is quite handy. There we go. Now both of those are in context for our queries via Ada. So now what's the best way to phrase what I want this to do? And that's the first step when using Ada, which is quite helpful. It requires that you solve the feature request problem in your head before you type. So rather than doing stream of consciousness coding, which it's very easy to slip into, you're forced to imagine, what am I trying to achieve? What's the shape of that? And to put that in a well-structured sentence, which Ada will turn into code. Let's go with that. Implement best match from search results to filter the items according to the Boolean result of a function, sufficient confidence worth reviewing, that we will code later, accepting the snippet property, a string as an argument, snippet property of each item. That should be clear. Let's see what it does. Right, and you can see that it's starting to figure out how it would code this. Got a lot of listed detail, what steps it's going to take, and then it outputs this diff block that it can implement in order to incrementally improve our repository. Let's see. Okay, I can see we've still got some problems with the code, but then we'd expect that because there's a function we haven't defined yet. So let's see what it did. Yeah, there's some indentation problems. I don't normally get indentation problems, but they're easily fixed. It's made some guesses according to what it can see in the repository and what I'm looking for in terms of a best match. Part of the fault of this mistake is mine. If I call it best match, it's expecting to return one match, and that's exactly what it does. It's going through each item in the items, and the first one that it finds, for which this function sufficient confidence worth reviewing comes back with true, it's going to return the link for that item. Now there's two problems here. Firstly, I don't just want the link, I want the whole item. Second problem, I don't want one best match, I want the best matches. I want this to work like a filter. I probably need to rephrase a couple of things. So let's change the name best match to best matches. So that's more clear. And let's change the return item to an array of links. But rather than do it manually, I'm going to ask Ada to do it. I don't always like to do tiny little edits with Ada. I could have done that quite quickly just by typing, but of course I'm illustrating how you can use it. What I generally try to do is to make the big first step of an architecture with Ada, because Ada has knowledge I don't. Because it's using GPT-4 in the back end and GPT 3.5 where necessary, it has a vast knowledge of different packages available in the Python world that I don't know about. Ada gives me the opportunity to say what I want and for it to decide what packages to install. There's positives and there's negatives for that. It might choose packages that are not brilliantly maintained. It might choose packages that are light and only for a restricted purpose that you've just asked it for, when a more general package will be needed in future, because you know that in the context of your brain, we can deal with that. You can always explicitly tell Ada to stop using an old package and switch to a new one. And I've certainly done that before and it's worked fine. There were some errors back here and I'm interested to see how it handled them. Yeah, this is something I referred to previously in a prior video, looking at how AutoGen might be compared with Ada. This is the kind of confirmation that Ada is engaging in conversation in the background with GPT-4 that is more nuanced. There's some underlying checks to make sure that what comes back can actually be turned into code. Yeah, it's done exactly what we've asked. Perfect. And we're going to ask it to code the next function that isn't yet defined. So this time I've given it quite a bit more detail to work on. So I've asked it to implement sufficient confidence worth reviewing as a function that prepares a string of the following format. So now you can see I'm preparing a prompt. Company name is a company directed by director name that focuses on industries. Estimate your confidence at a website at URL described by the snippet. Snippet might belong to company name. All these capitals are going to come from variables that I have access to in the global scope. Respond only with a probability number between 0 and 1. It seems to be, at least in my currently implemented models where I ask it to give a number to that probability, it seems to be pretty consistent at giving me a number between 0 and 1 that is fairly reflective of the kind of probability that a human might come up with. We're going to use that as a completion that we send off to OpenAI. What we'll get back will be a string which we will then need to pass via a regular expression, because occasionally it adds a bit of extra text, like I estimate the probability to be XYZ. We just want the XYZ. So we want to pull that via a regular expression and return that as a number. And if the number is greater than 50%, we're going to say that's good enough. If the get completion returns anything else, we'll wait 5 seconds and try again. So it's gone through this and it's been implementing those things. So let's see what it's come up with. Here it defines the function, sufficient confidence worth reviewing. I didn't tell it how to get this data. I didn't tell it how to get the company name. I didn't tell it how to get the director name. I didn't tell it where the URL was. So it knows that it's going to have this stub of a function that we're going to have to deal with and implement properly. It's even added a to-do comment. This is absolutely brilliant. And this is exactly what you want from something like Ada. You want it to make a whole bunch of best guesses that save you time. Okay, so now I want to be a bit more bold and see how much it can do itself. So I'm going to ask it to simply implement get completion using the OpenAI API. I can see an error here that it's unaware of. It's chosen the TextDaVinci 002 model. They've moved on from that, and TextDaVinci 002 is about to be defunct in less than a month's time. So I don't want to use this. I'm going to replace that with a more recent model. GPT 3.5 Turbo will be fine. So I might use this model. So we'll copy that and we'll ask Ada to implement it. Let's go to main.py and we'll run it. Okay, so all this is what it's done before. Unbound local error, no message. We'll take this and without even thinking about it, we're going to come back out and tell Ada the problem and let it deal with the issue. Well, the first thing I notice here is that we are right to use a regular expression. The first couple came back exactly as we'd hoped. The response was a pure number 0.9. This one is a response where we needed that regular expression to pull out the number, because it has still not just responded only with a probability number between 0 and 1. It's responded with quite a lot of text in which it includes a number between 0 and 1. And that's the kind of thing these large language models do. That's why we use a regular expression to pull out the number. I have another bit of Google food to do. If I want to find a website that belongs to a certain business, that business will have its own domain, and so I don't want any deep path results. Let's see if Ada already knows how to do that. Okay, so we had to do a couple of backwards and forwards to try to get this to work the way that I wanted. It started with some string manipulation for URLs, and I instructed it to use a proper URL parsing method. It started by trying to output the base URL for all of the search results, when actually what I wanted was only the search results that are a base URL. That's all now finished, so let's see how it runs. Okay, this is looking pretty good. We've prepared the way by implementing a function call for best matches from homepage text that's going to scrape the homepage for the links that we have confidence that are worth reviewing and return whether they're consider the best match or not, and we'll get a filtered list again. So you can see I said implement best matches from homepage text that scrapes the visible text content of the website from item link and provides it to a new function, sufficient confidence based on homepage, similar to sufficient confidence worth reviewing. I'm not giving it a vast amount of detail. I want to see if it can succeed with that alone. All this text is from our homepage website. It's consistent with us being the company that we are, working in the industry that we do. And when passed on to OpenAI, it tells us, I am 90% confident that the website belongs to Aegis Accounting based on the consistent use of the company's name, descriptions of their services, and testimonials from satisfied clients. So again, that's very wordy, which is why we need the regular expression. So it does work. And now we have figured out how to look at the snippets of search results and filter away all the ones that probably aren't anything to do with that business. We've also figured out a way to look at the ones that are left and figure out if they may be to do with that business. Now we need to find contact details. Okay, so I've prepared the way by uncommenting this line with the Scrape Company website function call, but I've made it totally empty. I could have asked Ada to do it from the outset. Never mind. We will drop search Google as we're done with that. And we now want to add Scrape website. And we're going to implement Scrape Company website. Now I need to give it some clues as to how to do that. I may try and get JSON output from the API. I'm going to look at the homepage and I'm going to look for a collection of different kinds of links that I would normally expect to see on a homepage. Places that contact information are commonly found. Well, the homepage itself, we want to look for a contact page, although that may just be a form. An about page may include that kind of information. We might need to look in a privacy policy or in a terms and conditions. When we look at the homepage, we should be able to figure out, can we find those other pages? And then we should look at them each in turn until we have enough information to proceed. Okay, so it took a little bit of backwards and forwards, and then I went outside of Ada to try and figure out regular expressions that would properly match a UK format telephone number. It is the kind of thing that GPT-4 and ChatGPT don't quite handle that well. Regular expressions are tricky anyway, so of course I went to the absolute classic website, Regex 101, and just built it there. I know what formats I will see UK telephone numbers in, and so I was able to put that in and make that work. Now that that's in, we've got it working and it's scraped the proper details off our website, no problems at all. It also puts it into international format and makes sure that it's a unique set. Now we can start looking at links from that page and then dig further in. So what we need to do now is find all the links on the page and essentially compile a list of them, the link description and the href attribute. And so I've got a command here for Ada to try and do that for us, provide a new function called scrape for links, takes an HTML strings its argument and returns a markdown formatted list comprising all the links in the web page in text and href pairs. Hopefully that makes sense. Okay, let's see what it's done. So scrape the links. It's using Beautiful Soup as I would have expected. It's going to find all the anchors, find the href, brilliant, and the text. That's ideal. So the reason I've used Markdown is I know that that's a pretty good format to put into large language models. They seem to understand it. What I'm now going to do is I'm going to be asking a large language model which of them are an about page, privacy policy page, and so on and so forth. I'm going to get it to extract those and return them to me, and I'm going to need to use JSON format. So for this one, rather than using the old completions API, I'm going to need to use one of the newest models in the chat completion API responding in JSON format. Okay, so this feels ambitious, but we're going to give it a go. We're asking it to implement a function called getRelevantLinks, which is going to take that markdown that we've generated as an argument. It's going to provide it as a prompt to the OpenAI chat completions API, calling specifically the GPT 3.5 Turbo 1106 model. This is the one that has the enhanced ability to respond with good, proper formatted JSON. Chuck all that markdown in, and we're hoping to get an object completed of the format contact page, about page, privacy policy page, and terms page. I've said terms because I want to match terms of service, terms and conditions, all that kind of stuff. Get relevant links. Okay, it should load that from the environment. We can correct that. That's the model. Chat completion.create, we've got the model listed, we've got these messages, we've got that content. I don't think it understands about the JSON mode. So JSON mode's pretty new, so it's not a surprise that Ada hasn't managed to pull information out of GPT-4 about how to implement it. It's the same sort of looking thing that we were doing before. We just need this extra line here, so I'm going to copy that, and that should do it. So this is quite a helpful error message that's come back. This is from OpenAI, and it tells me messages must include the word JSON in some form to use response format of JSON object. Actually, at this point, I realized that Ada basically didn't give any prompt whatsoever. It's just taking the links and firing them straight through to OpenAI. So let's give it a proper prompt. So what's quite useful about Ada is it has this Ada chat.history.md, so it keeps this markdown format saved content, which is really useful because it includes the text I'd already written. So I can copy that into the prompt. So here we have return JSON in the following format based on the links provided: contact page, about page, privacy policy page, terms page. Here are the links, and there I've got the markdown added onto the end. What can I say? That's absolutely perfect. The about page, it's found. The privacy policy page, it's found. And the terms of the service page, it has found. So now we can go on and scrape all three of those. So a very simple bit of code now added. For each of those links, we're going to get the link using requests library, and we're going to add them to the existing emails and phones that we've found. And this list set is a way of making sure we've only got unique values in there. We have no duplicates. So you'll probably have noticed the multiple lighting changes, and that's because of course quite a lot of time has passed since we started this. The problem that I've found that we've hit now is nothing to do with our capability of using Ada to develop software, but just challenges with the actual thing we're trying to do. In particular, one of the problems we've got is we're looking at these pages that exist under our domain, and we're unable to find information that I know is there. I know there are emails on this web page and it can't find them. Our domain is protected by Cloudflare, and Cloudflare includes protection against scraping of email addresses. These quite simple attempts that I'm making to scrape information off websites, they're going to have real mixed success, but for the purposes of completing something with Ada, we're going to push through and finish it. We're going to accept that maybe we won't get everything that we want. Over the course of about 15 to 20 minutes, we've hammered through about 100 of these prospective leads and found 3 sets of contact details, and it's an order of magnitude faster than it was before when I was having to do all these steps manually. It's been a fairly longer process coding than I wanted, but the result is something worthwhile. And what's really handy is that I do have a billing update showing how much it's cost to do all this. This is actually fairly easy to figure out because GPT-4 is what Ada uses, and so you can see here that the usage of that is fairly low, $5, but that is the development cost of the code that we've been working on mostly today. And the usage cost, yes, there are GPT 3.5 calls in Ada as well, but most of this will have been the actual usage, 27 cents. So to speed up this whole process by orders of magnitude has cost a handful of dollars to develop it, and now to use it over and over and over again, a handful of cents. That's pretty valuable. So in conclusion, how much time has Ada saved? Well, I'm pretty sure this would have taken a lot longer time if I hadn't have used Ada to shortcut some of the things that I'd have just got wrong the first time round and would have had to have spent ages Googling. So to use Ada to shortcut that and to get straight to something that has the right structure is brilliant. The first pro and con is it helps you jump to the implementation. So you have the idea, you write it in natural language, and it produces code. That's a great pro because it means you get there quicker. It's a con because when you research what the implementation should be, you'll pick up ideas as to how this is typically designed and implemented by others, and that can be useful. What you tend to find with Ada, just like if you're using ChatGPT directly or Bing directly, is you'll get a snippet that solves a problem. In the context of me writing scripts that run linearly, that's not a huge issue, but I think the chance that you're going to develop a perfectly well structured interdependent repository that is more complex than that, I think you're going to find it challenging to use Ada unless you already have a design in mind and know therefore how to ask Ada to do the right thing by using the right natural language. Another pro is it shortcuts the researching what package to use. In Python, just like my experience with Node.js and JavaScript environment, doing server-side stuff there, I would be looking at npm at all the packages and researching which ones are well kept, which ones are up to date, which ones seem like they have the API interface that best suits my use case and how I want to use it. And that's all quite a big piece of research. When you try to just implement what you want in natural language with Ada, it chooses a package based on what it thinks. It's a pro because, again, it shortcuts all of that research time. It's a con because it may choose things that are kind of defunct or not the way that people generally do things, just by virtue of when you asked it that one time, it's chose a really odd left field package that exists, but nobody really uses. The design paradigm is not a choice that Ada can properly make, because it only has the context that you've given it in language and the structure of the repository so far. So bringing it into an existing repository to add a few tweaks, fantastic. Bringing it into an unstructured repository to make a start, fine. But somewhere in between it becomes a bit tricky, where you probably around that refactoring time where things are getting complex, Ada's not going to automatically do that for you. You would have to explicitly tell it to do that. I haven't tested that here, and I'm sure it would have some success with doing it, but it would have to be an active developer decision to structure things and restructure things throughout. One of the other things, it forces you to chunk down what you're trying to do into bite-sized pieces that you can express in a paragraph. That's quite useful. I'm used to having a Kanban board where the next little feature or tweak is no more than I could fit on a sticky note. That's also very useful if you don't actually have a long sustained time to focus on coding. If you're like a bedroom coder, for example, and you only have bite-sized availability of time to actually move forward with your project, then chunking it down like that is quite a useful thing to do. I'm going to continue to use Ada. I find it really useful. I think it's going to be always a tool in my arsenal that I go to very quickly. Bing has become that for figuring out is something possible with code, and then Ada is now that for do the first draft of it and tweak my existing code base. That's, I think, where I'm going to use it most. By and large, it's a great piece of software, and I'm so pleased that I'm coding in a world where it exists and I don't have to get lost in a Stack Overflow time sink for hours. So what am I going to do next with Ada? Well, what you haven't seen today is starting a project from scratch. And I want to do that on a particular problem that is really interesting and exciting, but is nothing to do with Aegis accounting. And so I'm going to be doing that on a new second channel that you can follow. There'll be a link in the description to the video shortly. It is called Making with AI, and I'm going to be using it to do just some interesting stuff. I think my first idea is going to be, can I make a local LLM work behind a Signal API so I can literally message with it when I'm out, either an AGI or an autogen, so it can actually do stuff on my behalf on my machine from Signal messages. That's what I'm shooting for. I think Ada can help. You'll find that on the new channel. The link will be in the description as soon as it's done. Until then, I mean, I've mentioned autogen. Perhaps that's something you're interested in, especially if you thought autogen was something you could do coding with, and yet today all you've seen is Ada. If that's the case, there's a disambiguation that's quite important to understand between the purpose of autogen and the purpose of Ada. And if you want to know more about that, check out the video that we recorded all to do with it. I hope you found that interesting. If you're interested in that video, go look at it. Otherwise, I'll see you next time.